Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 21, volume of composite solids. Classwork exercise 1. So first of all, let's just discuss what this chapter section is, or this unit. Volume is length times width times height in a rectangular prism, but in other shapes it's the base area times the height, depending on what the base is. And of composite solids, well, what does composite mean? Okay, so if I go to Merriam-Webster's website, the definition for composite is something made up of distinct parts or elements. Okay, so we're taking the volume of different parts of shapes that create a total shape. So write an expression that can be used to find the volume of this chest shown below. Explain what each part of your expression represents. Assume the ends of the top portion of the chest are semicircles. Okay, so that means right here. So what I have done is I've drawn this out and I'm going to split it up. Okay, so I drew this, and what I'm going to do is I'm going to separate these. So this is a rectangular prism. And this is, I couldn't get the arcs to go all the way down, but you get the idea. This is, and if I rotate it, think of it as a semi-cylinder. It's a cylinder cut in half because we were told to assume that the ends were semicircles. Okay, so I'll just take these two shapes out just like this, and we'll do the problems in parts. Okay, composite solids. So what are our composites? What are our pieces? Individual components, a rectangular prism, and a semi-cylindrical prism. Okay, so the volume equals the base area times the height, but our base is a rectangle, so volume equals length times width times height. Let me do it this way. So my base area, is this end here, this rectangle. Okay, this is our base over here. And the base of this is the semicircle. So volume again equals the base area times the height. But in this case, the volume, or the base area, is a semicircle. Well, the volume, or the area of a circle is pi r squared. So it's going to be 1/2 pi r squared times height. So those are the two formulas we're going to use, and now we're going to substitute in our givens. So the volume is going to be of this length, okay, of the base, length times width, which would be 4 times 6, and the height is this distance here of 15.3. Okay. So then I'm going to simplify this, and 6 times 4 is 24 times 15.3. Okay, so the volume of this portion is 367.2. Feet cubed, or cubic feet, right? Feet to the third power. Okay, so let me just erase these now. Okay, so now we're going to go on to this. Volume equals 1/2 pi. The radius of this semicircle, okay, if this is a semicircle, here's its center. Well, if the diameter is 4 feet, the radius is 2 feet squared times the height, which is that 15.3 again. So when I simplify this, I get 1/2 times pi times 2 squared, which is 4. Well, 4 times 1/2 is just 2. So it would be 2 pi times 15.3. And since it's a decimal, I'll use parentheses instead of this dot for multiplication. So 15.3 times 2 is 30.6 pi feet cubed. Okay, so it didn't say to solve it in this situation here. It just said write an expression. Okay, and expressions don't have equal signs. So I just wanted to explain all this to you. So the expression would be this right here I did change to black. You all see that, right? This right here added to this. So my expression is going to be 24 times 15.3. Actually, I should go up one more line. So let me do that. This is my expression of all my information. This plus this. So my expression for part A would be 4 times 6 times 15.3. And you add that to the top, which is 1/2 pi 2 squared times 15.3. Okay, so there's my expression. The volume of the rectangular prism plus the volume of the semi-cylindrical prism. Now B says, what's the approximate volume of the chest shown above? So now I would do these steps here. So, okay, so I just copied these down here, and now I'm going to add the two. So it's going to be 367.2 is the volume for the rectangular prism. So this is actually, what is the approximate volume of the chest? So this is the prism. Use 3.14 for an approximation of pi. So then I just need to finish this half. This is done, but now I need to do this. 30.6 times, using 3.14 for an approximation. And so let me fix that. Since it is an approximation, I'm going to show that as an approximation. And then I will use my calculator. 30.6 times 3.14, enter. And so the volume of this portion is 96.084 feet cubed. So then I'm going to add these. So 367. So the total volume, let me use black for the total. The volume is 367.2 plus 96.084. So the volume is, okay, this is going out 3 decimal places, so that won't change when I'm adding. 2 decimal places, this is only 1, so that 8 won't change. 0 plus 2 is 2. 6 plus 7 is 13, carry the 1. 9 and 1 is 10, and 6 is 16, carry the 1 to the 3, and I get 463.284. Round your final answer to the 10th place. Always read the question when you're done. So I'm going to round this now. So volume, and it's an approximation, so I should have this. Volume is approximately 463.3 cubic feet. So there is our final answer. Okay, number 2A says, write an expression for finding the volume of the figure. It's an ice cream cone and a scoop of ice cream shown below. Explain what each part of your expression represents. Okay, so this is a sphere. We will represent that as being our ice cream. And here is an ice cream cone. Okay, so the first thing I'm going to do is write an expression. So first I'm going to write it as an equation for the formula. Volume of a sphere is 4/3 pi r cubed. The volume of a cone is 1/3 pi r squared times height. Okay, so this is going to equal 4/3 pi, and the radius is 1. The volume is 1/3 pi, and the radius is 1, and the height is 3. So my expression will be 4/3 pi 1 cubed plus 1/3 pi times 1 times 3. Okay, and then you'll need to explain what these represent. As I was speaking, I explained it, so I'm going to move on. It says B, assume every part of the cone can be filled with ice cream. So in other words, we're going to fill it and press it down so there's no air in here. It's going to be filled in solid, and then the scoop will be sitting on top. What is the exact approximate? I like that. What is the exact approximate volume? Well, which is it, exact or approximate? That's funny. Of the cone and scoop. Recall that exact answers are left in terms of pi and approximate. Oh, it's asking for both. Okay, that does make sense then. Exact and approximate. So they want both. One in terms of pi and one using 3.14 as an approximation. Round your approximate answer to the hundredths place. Okay, so we always come back and read that again. But here we go. So I'm going to go back to blue, and I'm going to solve this. So I have V equals 4, let me try that again, 4/3 pi. R cubed, which is 1 cubed, is just simply times 1, or simply 4/3 pi. That's the cone. Now, or the ice cream. Now the cone is going to be 1/3 pi times 1 times 3. And that is going to equal 1/3 pi. And 1 times 3 is 3. But what's 1/3 of 3? 1 times 3, this is a 1. 1 times 3 is 3. 1/3 times 3 is 1. So it's just simply pi times 1, or pi. Okay? So the volume, total volume, is going to equal 4/3 plus 3/3, or 7/3 pi. Okay, so that's our approximation. Okay. So let me see. It says that they want the exact and approximate volume of the cone and the scoop. So how about I just do the approximate right below first? Let's do that, and then I'll go to the total. So the volume is going to be approximately, and this is going to be 4/3 times 3.14. So always put your fractions in parentheses. 4/3 times 3.14. Enter, and I got approximately, and it says round to the hundredth, 4.19. And it is inches cubed, cubic inches. Okay, there's the approximation of the ice cream. Now we're going to do the approximation of it's actually the scoop. Now we're going to do the approximation of the ice cream that's in the cone. And that's going to be just simply pi. Well, that is 3.14 inches cubed. Pi is 3.14. Okay, so there's our approximations. Okay, so now we're going to do the total, the totals. So the exact is going to be 4/3 pi plus pi. So the volume is going to equal 4/3 plus 3/3, or 7/3 pi inches cubed. The approximation is going to be, now I'm not going to take this plus this, because that's rounded and that's rounded, and our results are going to be further off. So I'd rather take 7/3 times 3.14. Okay, and when I do that, it's going to be closer to our exact. And I got 7.33. Cubic inches. Now if I just added these, what would I have gotten? 4.19, 3.14, 9 and 4 is 13, 3. This time it came out to be the same. There was no rounding problems, but there could be. So here is our exact and our approximation. Okay, so if you got that right, treat yourself to some ice cream. Yummy. Okay, number 3. Write an expression for finding the volume of the figure shown below. Explain what each part of your expression represents. Okay, so this looks like a trophy because it said number 1 player right here. So this is a base, and this is the stem and a basketball sitting on top. So number 1 basketball player trophy. We're going to find the volume of this figure. So if it was solid and it was cast out of some type of like molten metal, then we'd want to know how much volume is in it. Okay, so here we go. For starters, we have a sphere. Okay, so I found these images. This is the sphere, the basketball on top. This is the cylindrical stem or base, or that this ball is sitting on, and this is the base, which is a square. Notice it's 5 by 5, so it's a square prism. Okay, so I'm going to label this up. So if this basketball is 5 inches in diameter, okay, then the radius is 2.5 inches, 2.5 inches. The cylinder is 6 inches tall, and the base is 1 inch, so the radius is 1/2. And this is 5 by 5 by 2. So it says to write an expression for finding the volume of the figure shown below. First, I'm going to write the formulas up here. V equals 4/3 pi r cubed. That's the prism, or sphere, I mean. The cylinder is base area, pi r squared got distracted by my phone. S-I-R-E, thought I said that, but I didn't. Volume equals pi r squared times height. And the volume of a square prism is side squared times height. And so my expression for this is going to be 4/3 pi 2.5 cubed. Plus the volume of this, which is pi 1/2 squared times the height, 6, plus, let me do these in different colors. Okay, plus, come on, man, plus x squared times height. Okay, so there is our expression. 4/3 pi times 2.5 cubed plus pi times 1/2 squared times 6 plus 5 squared plus times 2. Okay, part B says, every part of the trophy shown is solid and made out of silver. How much silver is used to produce one trophy? Given an exact and approximate answer, rounded to the hundredths place. Okay, so now what we're going to do is do this as an approximation, leaving it in terms of pi. Or that's exact, I mean. And then use an approximation. I guess we're going to use 3.14 again. It doesn't specify, but that's what we'll do. So, first of all, let's do exact. I'll do exact in black. Exact means in terms of pi. So I'm going to simplify this now. So volume is going to equal 4/3 pi, and this is 2.5 squared, which is 6.2, or 2.5 cubed. I don't know that cubed. 2.5 squared is 6.25, but 2.5 cubed is 6.25 times 2.5, which is 15.625. Plus pi, 1/2 squared is a quarter, times 6, which is 6/4 or 3/2 pi. Okay, 1/2 squared is a quarter, times 6 is 6/4, which reduces to 3/2. Plus 5 squared is 25, times 2 is 50. Okay, so there we have it. So the volume of this base is 50 cubic inches. The volume of the stem, which is a cylinder, is 3/2 pi. And the volume of this, now I just need to finish this up. I need to clean this up. And if I do this times 4/3, I get 20.83 repeating. And I'd rather leave that in fraction form, which is 125 over 6 pi plus 3/2 pi plus 50. Simplifying this, I can add these two. In order to add them, I have to have the same denominator, so I have to multiply this by 3. So when I do that, 3 over 3 is going to give me 9/6. And now I can add them. 125 plus 9 is 134 over 6 pi plus 50. Okay, this is, I can reduce this. Half of 6 is 3. Half of 13 is 6. Half of 4, so 67 pi plus 50. Inches cubed. So there is my exact. My approximation would be 67 over 3 times 3.14 plus 50. So my volume is going to be approximately, now if I take that 67/3, don't forget my parentheses, if I take 67/3 right here times 3.14, I get 70.12, so if I hit 70.126 repeating plus 50 equals 120, and it says round to the hundredths place. 0.126, so that would be 0.13 cubic inches. So there's my approximation, and here's my exact. Now to be more precise here, I should have parentheses right here because it's that inches cubed. Okay, next problem. Number 4 says use the diagram of scoops below to answer part A and B. Order the scoops from least to greatest in terms of their volume. Each scoop is measured in inches. Assume the third scoop is a hemispherical, half of a sphere. This is a truncated cone, remember? If that continued down, we cut the cone off. Okay, and this is a cylinder. Okay, so I copied these with the handles removed just to make it more clear. This is a cylinder, so first I'll write the formulas. The volume of a cylinder equals base area times height. So the volume of the cylinder, the base is a circle, which is pi r squared, times height. Okay. The volume of a truncated or cone that's been cut off is the volume of the cone minus the volume of the cut off cone. Okay, so volume of the whole thing minus the volume of the cutoff will give us this. So let me just move this down a little because I'll draw that picture. Or actually, let me move this up. Because if I take this and show the whole cone. Okay, so I just wanted to show this whole diagram to you. It was in a problem from, or it was in a previous lesson. So to find the volume of a cone that has been cut off, you take a proportion of the volume of the whole cone to the volume of the cone that's been cut off. Okay, so the cone that's been cut off would be with the base here. So you remove that and you set up a proportion. So you take the height of the cone that's been cut off, which is x, over the whole thing, which is x plus 1, equals the radius of the big one. There should be a 1 here. So it's x, the little cone, over the whole thing, x plus 1. So the whole thing is the big cone, and the radius of the base of that is 1/2. I'll put it as a fraction. And the radius of the little one is 0.375. 0.375 is 3/8. Okay, so I'll put that up there. So just so you know, 0.375, if you put it in your calculator, is 3/8. I just prefer using fractions over decimals. Okay, so if I cross multiply this, I would have 3/8 x plus 3/8, right? Because I'm multiplying this and distributing. This times this distributed, 3/8 x plus 3/8 equals 1/2 x, or 4/8 x, since we're going to subtract. So I'm going to subtract 3/8 x from both sides. Let me move this down. So if I subtract 3/8 x, subtract 3/8 x, then I get 1/8 x equals 3/8. Multiply both sides by 8. This is still in the way. Okay, so I'm going to multiply both sides by 8. Multiply this by 8 and multiply this by 8. The 1/8 times 8 is 1, are just simply x, and the 8's cancel, and I get x to equal 3. So x equals 3. So now I know the height of the whole cone. So the whole thing, all of this, is 3 plus 1, or 4. So the volume of the whole cone is pi r squared times height. So I needed to find this 4. Minus the part that was cut off, which is this down here, which is pi r. Okay, the radius of the little cone is 3/8 squared times the height, which is 3. Okay, that was probably the most difficult thing to do here. You had to remember this lesson from before, or this example from the prior lesson, I should say. I'm just moving all this stuff up a little bit. There we go. All right. Now I do the volume of this. Well, the volume of a sphere is 4/3 pi r cubed. But it's only half of that, so it's 1/2 of 4/3 pi r cubed. Okay, so I'm going to go back up. That was a lot of work. What did the question actually ask us? Order the scoops from least to greatest in terms of their volume. Each scoop is measured in inches. Assume the third scoop is a hemispherical sphere. Okay. All right, so now we're just going to substitute in our givens. So let's solve these. So volume equals pi. The radius is 1/2. So I'm just going to write that in here now. 1/2 squared times the height, which is 1. So volume equals 1/2 squared is 1/4, times pi is 1/4 pi, times 1 is still 1/4 pi. And this is in inches, so that's cubic inches. 1/4 pi inches cubed. So there's the volume of this. All right, so now I need to find the volume of this by substituting. So the volume equals pi. 1/2 squared is a quarter, times 4 is just simply 1, right? 1/4 times 4 is 1, so it's just simply pi, minus, and 3/8 squared is 9/64, so let's just write that, minus pi times 9/64 times 3. So the volume equals pi minus 9 times 3 is 27/64 pi. All right, so I'm going to do something right here. Move this v over. And 1 is 64/64 pi, right? So now the volume is 64 minus 27, which is 37/64 pi inches cubed. Okay, I need to fix this equation here. The volume of a cone is 1/3 pi r squared times height. I forgot my 1/3 right here. So this volume equals here. I need to have a third there. So volume equals 1/3 pi r. So this is 1/3 pi. Okay. So I need to change this here. So let me just erase this. Hello, eraser. Okay, so just get rid of this. Okay, bear with me. And so now I'm going to have volume equals 1/3 pi minus 27/64 pi. Okay. Okay, so in order to find a common denominator, all I did was multiply 3 times 64, because I know 3 won't go into 64, and 64 times 3 is 192. So I'm going to have volume equals 192. Well, what did I multiply 3 by to get 192? 64. Pi. So 64 over 192 is a third, right? 64 divided by 192. Enter, and it's 0.3 repeated, minus, this is going to have a 192 in the denominator, and I multiplied it by 3, so 27 times 3 is 81. So it's 64 over 192 minus 81. Okay, but then it's times 3. I forgot that, times 3. Okay, so right here, nine 64ths times 3 is 27/64. Oh my gosh. And there's a pi here. Pi times 27/64. Okay, so in order to get 192, what am I doing here? What about this 3? So I'm just trying to figure this out here. We have pi r 3/8 squared times the height, which is 3. 3 times 3 is 9. 8 times 8, or 3 squared, yeah, 8 times 8 is 64 times 3, which is 27/64 pi. Okay, I apologize for all these mistakes, but I'm forgetting my 1/3s in all these here. So this is 1/3 minus. Okay, so 1/3 pi r squared times height. I'm forgetting my 1/3. So when I have a 1/3 here, 1/3 times 3 cancels. So that leaves me with 9/64 pi. So I don't want to, so multiplying by 3 gives me 27/64. And the reason I was questioning that was because my value when I got down here, I was subtracting a greater portion, and this volume here can't be greater than the whole. So I was confuzzled. So therefore I researched and I found my mistake. And that's what you need to do. Okay, volume can't be negative. And when you come across something that doesn't make sense, fix it. And that's what I just did. So I apologize for missing those 1/3. Okay, but I did fix it. And so now we have 1/3 pi minus 27/64 pi, or that's going to be, or not 27, it's just 9, right? Because it's 9/64 because the 3's canceled. Okay, and that's where I was making my mistake because I was multiplying it by 3 and getting 81, and 64 is less than 81, so we're getting a negative value. So I really want to multiply 9 times 3, which is 27, and 64 times 3, which is 192 pi. Now this is greater than that, and I won't get a negative. Okay, so now I'm happy. 64 minus 27 is 37/92 over 192 pi inches cubed. Okay. V equals 1/2 4/3 pi r cubed. The r is a half. Substitute it in. 1/2 4/3 pi, and then 1/2 to the 3rd power. So the volume is 1/2, and I always do inside the parentheses first. 1/2 cubed, 1 times 1 times 1 is 1. So this will stay 4/3 pi. And this is times 1 over 2 times 2 is 4 times 2 is 8. Now I can multiply the inside and get 1/2. 4 times 1 is 4. 3 times 8 is 24 pi. Okay? So these two will make this for A2. And I will simplify. 2 over 24 is 1/12 pi inches cubed. Okay, so now they said to place these in order. Order the scoops from least to greatest in terms of their volume. So the least volume to the greatest volume. So if you aren't sure what 37 over 192 is, it's always easier to put things in order when they're in decimal form. So 37 divided by 192 is 0.19, okay, approximately. All right, so this is 0.19. And 1 divided by 12 is 0.08. So these are approximations. And 1/4 is 0.25. Okay, so we put them in order to least to greatest, 0.08, then 0.19, then 0.25. So that's the order of least to greatest. Rather than writing that, I will just say in order from least to greatest is this one, and then this one, and then this. Okay, and there we have it. The volume of this is less than this, and the volume of this is less than this. Okay, so part B says how many of each scoop would be needed to add 1/2 cup of sugar to a cupcake mixture. 1/2 cup is approximately 7 cubic inches. All right, so let's use our calculator and change this to an approximation. So 1/4 pi is 1 divide 4 in parentheses, and we're doing an approximation, so it's 3.14 is what we've been using, and hit enter, and that's 0.785. So the first thing I need to do is do an approximation decimal for all of these. So on this one, where'd my V go? V equals And so now I'm going to put 37 divided by 192 times 3.14, and I get approximately 0.605. Okay. And now I'm going to do the same for 1/12 pi. 1 divided by 12 times 3.14, and that is going to give me 0.262 approximately. Okay, so there are my three approximations. So we need to write an equation for all of these. How many of each scoop would be needed to add a half cup of sugar to a cupcake mix? 1/2 cups, approximately 7. So we want our result to equal 7. So let X be our number of scoops, and this is how much of a scoop this is. So it would be 0.785. X equals 7. This one would be 0.605. X equals 7. And for this one, it would be 0.262. X equals 7. Okay? And then in solving these, we just divide by 0.785 on all three of them. So I'll just do that all at once right now. Divide by 0.605. Divide by 0.605. We're solving for X. And divide by 0.262, and divide this side by 0.262. Okay, so 0.785 divided by it's 7 divided by, so clear, 7 divided by 0.785 is 8.9. My decimal's in the wrong place here. It's 0.785. Okay, and here X will be approximately 7 divided by 0.605. And that's approximately 11.57. And finally the last one. X is approximately 7 divided by 262. 7 divided by 0.262 equals approximately 26.72. Okay, now we can go up and read again. Round your answer to whole number of scoops. So now I need to round. So X is approximately 9 scoops. In this one, X is approximately 12 scoops. And obviously it should get greater on each one. And X is approximately 27 scoops. Okay, so we have answered the question. That is the end of lesson 21. Review this lesson summary and go do your problem set.